Hello class, this is section 2.1, so we're getting into functions now. So let's look at this first example. It says express a rule in function notation, and they give you an example. For example, square, then subtract 5. So x is your variable, you want to square it, and then you want to subtract 5, and that's why that would be the answer. So in this case, it says add 9, so they're referring to x. Add 9 to x, and then you want to take the square root, and then you want to divide by 2 at the end. So that would be the rule. So first they're asking you to add 9 to the variable, and then they're telling you to take the square root, and finally divide everything by 2. So that would be your final answer. All right, the second problem is telling us it's the same thing, now it's just in the opposite direction. They give you the rule, and you have to state which one it is in words. So it looks like they're adding 1, add 1, comma, divide by 9. So that would be answer choice, the last one. All right, for this piecewise function, it's called a piecewise function because it's broken up into two pieces. The first function on the top is defined only when x is less than 0, and the function down below is defined when x is greater than or equal to 0. So for each of these values, you want to see which one applies. -2 is less than 0, so that means you're going to go with the top function. So -2 to the second power is 4. All right, for the next one, -1 is also less than 0, so you're going to also go with the top function. So -1 squared is 1. 0, that's equal to 0, so you're going to go actually with the bottom function this time. 0 plus 9 is 9. 1, that is greater than 0, so you're going to go with the bottom function. So 1 plus 9 is 10. And 2 is also greater than 0, which means 2 plus 9 is 11. Here they want us to find the net change in the value of the function between the given inputs. So this is your input 1, input 2. So think of this as x1, x2. To find the net change, you would want to find f of x2 minus f of x1. All right, so in the first case, here they kind of label it differently. It's g of t. So just think of this as g of t2 minus g of t1. So if you plug this in, let's plug in the second one first. G of 7 minus g of -2 is what we're looking for. G of 7, if you plug that in, is 3 minus 7 squared, which is 3 minus 49, which is -46. Minus g of -2 is 3 minus -2 squared, which is 3 minus 4, which is -1. So the net change would be -46 plus 1, which is -45. All right, for this one, they want you to find the domain and the range. They give you the function, and they actually give you the domain already. So this is the domain. So they wanted in interval notation. So because of the little equal signs on the bottom, that means you want to include the endpoints. Inclusive, that means square brackets. If it didn't have the little equals on the bottom, you would have used parentheses. All right, as far as the range is concerned, you just need to plug in these values into x, and that's how you get your range. So let's plug in -8 first. So f of -8 is 3 times -8, which is -24. F of +5 is 3 times 5, which is 15. So your lowest point will be there, and your highest point will be there. So it's going to be everything inclusive from -24 to 15 is your range. All right, moving on. Find the domain of this rational function. This is called a rational function because it's a ratio of two polynomials. So the only thing that you have to exclude from the domain is anything that will give you 0 in the denominator. So what you would do is you set the denominator equal to 0, and that tells you which value should be excluded from the domain. You can't have x equal to 8 because if it is, you get 1 over 0, which is undefined. So your domain will be everything on the number line except 8. So everything in that direction is good, and everything in that direction is good. So in other words, it's the entire number line except 8. And so the way you would write that in interval notation would be everything from negative infinity to 8, excluding 8, union everything from 8, excluding 8 to positive infinity. So that's how you would want to write your answer in interval notation. Same thing here, the domain of this function. Whenever you have a function that involves a square root, you know that your answers, the argument, this is called the argument, can never be negative because you can't take the square root of a negative number. So in order to find out the domain, you have to make sure that the argument is greater than or equal to 0. So that's what you would do when you see square roots. You set the argument greater than or equal to 0 because you don't want any negative values inside. Otherwise, it would be no real solution. Subtract 8. T will be greater than or equal to negative 8. And on a number line, if you were to graph that, that would be greater than would be closed circle. Greater than would go to the right. And so that would be written as close bracket, negative 8, comma, positive infinity. So this would be your final answer in interval notation. That's the domain. That just means that any value within this interval would be defined for this function. Any value outside of this interval would not be defined for that function. All right, same thing, but now they combine the two together. They have radicals and they have a denominator. So let's take care of the denominator part first. So set the denominator equal to 0 and then solve x equals 6. However, x cannot be 6 because if it's equal to 6, then you have 0 in the denominator, which is undefined. So we want to exclude it from the domain. And up here for this radical, we want to make sure that the argument is greater than or equal to 0. So 8 plus x is greater than or equal to 0. Solve for x. All right, so on a number line, that would look like this. You have negative 8 over here somewhere. You have positive 6 over here somewhere. Open circle because x cannot be 6. And then here, you want this to be a closed circle because it's got the equal sign on the bottom. And you want to shade all the values that are greater than or equal to that. So you want to shade everything greater than, but however, don't forget to jump over that 6 because 6 is not part of the domain. So this is your solution set. Using interval notation, we would say negative 8 inclusive, comma 6 exclusive, union 6 exclusive, comma infinity. That is our final solution set. All right. And the final problem is one of these word problems. It says an internet bookstore charges $20 for shipping for orders under $100, but provides free shipping for orders of $100 or more. The cost C of an order is a function of the total price, X, of the books purchased given by this piecewise function. So if you spend less than $100, it's only going to cost you, it's going to cost you the amount that you're spending plus $20 for shipping. If you're spending more than $100, it's just the cost without the shipping. So if you're spending $70, that's less than 100. That means you're going to use this function, which is 70 plus 20, which is $90. If you spend $85, that's still less than 100, so it's going to be 85 plus 20, which is 105. And if you spend $100 even, that's going to be the second function because of the equal here, so you're only going to spend $100. And And if you spend 105, that's also greater than 100, so you're just going to spend 105. And that does it for this